Discuss about three types of angular momentum type mass flow meters, and we will also discuss some flow meters which are not as such part of the syllabus, but one flow meter, particular type of flow meter, Coriolis type of flow meter, and other flow meters. In module 4 we will be discussing other types of flow meters, even ultrasound, all those things. So let us start off with this. Say this is a recollection from the thing which we discussed last day. Say it's based on the angular momentum. So you are imparting a momentum to the fluid, and this fluid is going to strike some other rotating component, and it will the momentum will be proportional to its flow. So it will be imparting a torque to this other mechanical component, right? And the torque will be proportional to the flow. That is the basic idea. So we understood that this particular value, torque, is proportional to the moment of inertia and the angular acceleration, and then we also, from the Newton's second law, this angular momentum is equal to the moment of inertia and the angular velocity, and the moment of inertia is defined as mr square, and so substituting it, we got this expression, and finally we have mass flow rate in terms of y, which is the torque, and then the radius of gyration and angular velocity. So the idea is that you will give an angular momentum to the fluid, and then you will be measuring the torque. Radius of gyration is constant for that particular system, so you will be getting the mass flow rate. Now an extension, so based on that we discussed the impeller turbine flow meter, where you have the fluid which is coming in through this path, and then the impeller, this is the impeller, and this unit is the turbine. So impeller is driven at a constant speed. So you will have a synchronous motor to drive this impeller mechanism, and this is imparting angular velocity to the fluid, and this is going to, this impeller and the turbine has pathways, tubes through which this fluid can flow. Now when this fluid flows through this turbine, fluid that exits out from the impeller flows through the turbine, it is going to rotate this turbine. Now this rotation will be producing a torque, so it will be causing this turbine to rotate, and torque will be proportional to the turning effective forces, the torque. So torque will be proportional to the angular momentum. So if you have a spring, the coil mechanism, spring, and the needle mechanism, deflection mechanism, which is similar to that of a galvanometer, you are going to record this thing. So you are going to get a measure of the mass flow. So this GIF file which is shown here, that is illustrating this thing. So again, one thing is that you have it is basically the concept of a AC generator. You are recording a signal using this pickup mechanism at this point, and the frequency will be proportional to the angular velocity, the rate at which this fluid flow. So that is the basic idea in impeller turbine flow meters. Even very big size impeller turbine flow meters are available. We discussed this thing also, impeller turbine flow meter used in a coffee vending or coffee tea vending machine, and I encourage you to make this. There is a programming language called PLC, programmable logic circuits, that is ladder language. If you are enrolling for this Bosch Hexroth course, you will learn PLC programming. Besides, you will learn something in the process control lab, or which is there part of your syllabus, has PLCs there. So Dr. Binu, he will be teaching you those things. So it is, in fact, ladder language is quite simple. I tried. It's an extension of your digital paper, logic circuit design, which we did last semester. So it's a simple language. You just draw just like a ladder. You can involve the components. Draw. It's drawn like straight lines and some symbols. So ladder language programming can be used. You can use 805 programming. You can use PIC programming. Even a PIC microcontroller will do. Now with an Arduino board, you can do almost all the things related to this TV vending machine. You can connect relays, analog signals, everything is there. You can only disadvantage you will be facing is that you won't be having Wi-Fi connectivity. Suppose you want to remotely monitor the status of the water, everything. That is not, and then there are also you can put a Wi-Fi shield and all those things. We saw this flow meter. Now coming to today's discussion, that is constant torque hysteresis clutch flow meter. So this is in fact an extension of the angular momentum type of flow meter. So here we know this. We have already seen this relationship. We have already seen this relationship for the mass flow rate. Now you need in this type of flow meters, you need make a torque measurement. You are assuming this torque to be constant. How to provide a constant torque to the fluid is that is done by using a mechanism called as a hysteresis clutch. Hysteresis clutch is a way to transmit power electromagnetically. So you know the clutch in a vehicle, clutch. Those who drive car, everything. What is a clutch used for? What is a clutch used for? Hello, can you hear me? What is a clutch used for?
Smoothly changing the gears.
Right. Right, it is to change the gears. It is to transmit power from the engine to the wheels. Right. It is a way to transmit power from the engine to the wheel. That is why, say, if you are not at the correct speed and you are shifting the gears to a higher gear, you are going to say you are basically experiencing the laws of physics there. So your clutch plate is coming in contact with your mechanism that transmits power to the wheels. Now in hysteresis clutch, this contact will not be there. It will be, this contact will be an this will be an air gap. This will be an air gap. This will be an air gap, and you will be transmitting power by a coupling, electromagnetic coupling. That is the idea there. We have a figure there. We have a figure. So say here you are holding y and your radius of gyration is constant, so you have this simple relationship. This is proportional to the angular velocity, right? So this is the idea. You will have this is not a hysteresis clutch flow meter. I did search several places. I couldn't find a figure for hysteresis clutch flow meter. But I have shown the constant torque, means the constant torque hysteresis plus flow meter. I didn't find a figure. I have shown the impeller turbine flow meter here, so that just to make some concepts clear, you will have to visualize a bit. That's what. What is done is that you assume this mechanism has the synchronous motor. So a synchronous motor is placed. I'll just use the pointer. A synchronous motor is placed at the center of the flow assembly, and this is magnetically coupled to this thing, impeller. Okay, impeller that is located within the flowing process tree. Okay, so some way the flow comes in through this path, and some way I don't I won't be able to per se say how this is there. So this is okay. I'll clear this. There is a error on this impeller, not the turbine, impeller. So there is a synchronous motor. There is a synchronous motor here, and this is a synchronous motor, and this is there is air gap between, this is an air gap between this synchronous motor and the impeller. Okay, and you will be coupling energy to this impeller with using this hysteresis clutch. So this is an electromagnetic clutch. Say this is the hysteresis clutch mechanism. So this is developing a torque through a magnetic air gap, and since this has a relationship like hysteresis loop, torque current relationship is like a hysteresis loop, it is called as hysteresis clutch. So here you see the motor, and this is the driven mechanism. This is a motor which is a driving unit, and this is a driven element, and you are coupling by an air gap. This is not to be carried over to the what do you say, the concept explained the hysteresis clutch. We will go back to this again. Okay, so what I am explaining, what is an hysteresis clutch. So you don't have any mechanical coupling, there is just an electromagnetic coupling. So you increase the magnetic field strength, you are going to transmit more power. That is what you are going to transmit, more torque, right? Your magnetic field current is increased, you are going to torque is increased. Now there is a smooth transmission of power. So this particular type of mechanisms are used in, say, bottle screwing mechanisms. That is, this is a conveyor belt where the bottle comes, and there this hysteresis clutch mechanism is there, and in assembly lines, say they will just screw on these caps. The question is, why can't they put people there and screw on these caps? That is a thought. Okay, fine. But automation means people are going to lose jobs. Too much amount of automation. So automation is happening in all domains, even from factories, your IT sector. Code generators are there. You need people to debug codes now. Codes can be automatically generated. Then you need a good engineers to debug these codes, test these codes, and make them far more efficient. So that is the trend that is going on. That's what we were having a lecture by industry people. A department had organized a lecture. So a person was sharing this thing. A person from the industry was sharing this idea. So this is the hysteresis clutch. So this is another figure which illustrates how this mechanism works. This is the hysteresis ring. That is the coupling. This is the hysteresis ring. There is a coupling from the outer, say, the motor to this, the impeller mechanism, and it is driven at a constant torque. Right. Coming back to this. So so the torque is constant. So Y is going to be constant. So the rotational speed is inversely proportional to the mass flow rate. Right. This relationship. Right. So this is the constant torque hysteresis clutch mass flow meter. Constant torque hysteresis clutch mass flow meter. Again another type of flow meter is a twin turbine flow meter. This is also an angular momentum device. Here there are two turbines. Which are mounted on a constant shaft. So turbine, when the notion of a turbine comes, your mind straight away goes to power stations. These are much smaller things. Here you are going to measure flow. Obviously you can use such mechanisms in power stations. So here they are mounted on a constant shaft, and there is this connection is by a calibrated torsion bar. Okay, and above each of these turbines you have a pickup coil. These are going to generate a alternating field. Okay, and so a magnet is located within each turbine, and this is picked up. The frequency of this rotation, how this magnetic field is cut, that is picked up. north south aanallo, so you can pick up. So, and these two turbines are having some phase shift. Deliberately I have introduced. If you observe this turbine leaves, you are observing from this side, that's why, but another view will give you a different angle, and so each turbine is having a different blade angle. So obviously they will be running at two different angular velocities. So, and this torsion beam is going to restrain this motion. So, and because, and at some they will be because of this fluid flow, this rotate, but they will be rotating at some average velocity. Okay, and but they will be but their rotation will be out of phase. Angularly they will be having some phase shift. So this angular phase shift is a function of the angular moment of the fluid. So the angle gives the value of the torque, which is proportional to the mass flow rate. That is the idea in a twin turbine flow meter. So this is the best explanation I came across. That explains the concept. So you are trying to restrain these flows of these two and make them, even though they are designed at with different fan blade angles, they will be rotating with, because of this torsion bar, they are going to rotate at some constant angular velocity. And finally, what happens? Say the phase shift, the angular phase shift will be a function of the angular momentum of the fluid. So and that will be proportional to the mass flow rate. So that is the summary of whatever topics are there in the third module. Then other type of flow meter, there is a Coriolis type of flow meter. So Coriolis type of flow meter, which is used in oil and gas industry. So this is a Coriolis type of flow meter. So this is your there is a differential, the pressure sensor is also there. Okay. So what happens is that the fluid within this chamber, so the fluid, there will be two tubes. What is Coriolis force? Coriolis force, first thing. Geography people, please tell what is Coriolis force? Coriolis effect, that is another thing. Yeah. Before we discuss Coriolis force, what is Coriolis effect? I say it is Coriolis. What is Coriolis effect? എന്താണ്? People, you haven't learned geography? Disconnect power. Why disconnect power, Siddharth? I didn't hear. Hello? Disconnect power. I think he mentioned something about yes, right. Clutch. Right. I forgot about the clutch. Right. Yeah. If I look straight at your face, I can understand really. I was thinking about this Coriolis effect. What is Coriolis effect? People say, I'll just pause the recording. If you are wary of being recorded in camera, I'll just pause the recording so that you can tell. So continuing, so this Coriolis, yeah, right, in a frame of reference, force that acts on an object in a frame of reference. Now here, if you go to this, I encourage you to go to this link, Emerson's. Emerson is a company which is doing quite a lot of things in instrumentation. It's a good company. I don't think they come for placements in our place, in our college, but I have come across a lot of resources from Emerson in instrumentation field. They are making a lot of instrumentation devices, all those things, software, hardware, all those measurement equipment, all those things. They are into several fields. Emerson, even in we had UPS, I suppose, a couple of years back. So network devices also I have seen their Emerson devices. Emerson. This Coriolis flow meter, there is a 4-minute long video which illustrates how this thing works. Basically, there are two tubes within this bigger tube. So the fluid that comes in, the oil, crude oil for instance, it will be split into two flows, and during this flow these two vibrate, and these tubes, they have some magnets along their length, and you will pick up the difference, the phase shift between these two signals. So the vibration will be in a sinusoidal wave. Each of these tubes will be vibrating as sort of a sinusoidal wave, and there will be some phase shift between these two that will be used to get an idea of the mass flow rate. That is the basic principle. Coriolis effect, what is a Coriolis mass flow meter. So in fact, the Coriolis mass flow meter is one of the earlier earlier generation, one of the first, the first flow meters that was used in the oil and gas industry. It has evolved over a period of time. So, and it's a very accurate device. In fact, it's a very accurate device. It gives a very accurate thing, measurement of the mass flow. Okay, so that summarizes the ideas from modules 3. We'll continue with topics from module 4 now. Okay.